Okay, students, so let's get started with the past papers of O levels and IGCSE physics related to the topic of simple magnetism. Rarely there are questions in the examination that are solely related to simple magnetism. So I just found one to two questions related to simple magnetism. Other questions related to simple magnetism are covered in the electromagnetic induction video. So I have placed them there. A question solely related to magnetism is this. So let's start with it. A magnet is placed on a bench as shown in figure 8.1a. Okay. And P of a rod is held above each end. Okay. So end P of the rod is held above each end of the magnet in turn as shown in figure 8.1b and 8.1c. Okay. One end of the magnet is lifted off the bench in both cases. So if you are placing end P, it is also attracting north. If you are placing end P near the south, it is also attracting south. If a magnetic end or a magnetic pole is attracting both north and south, what kind of rod will be this? Iron. And what type of a magnet will be this? Temporary magnet. So let's write it here. Suggest what the material rod is made from. It is made from iron. Explain how the iron rod lifts each of the magnet off the bench. Okay, so how does the iron rod lift the magnet off the bench? So what can you say? As the magnet comes closer to the rod the rod induces, or you can say iron rod if you have deduced that it is made of iron. The iron rod induces an opposite pole at end P. This causes the opposite ends to attract. This causes the opposite ends to attract. Simple as that. Let's further move ahead. Figure 8.2 and 8.3 shows views of a current carrying conductor downward through a horizontal board. Okay. On figure 8.3, draw the magnetic field lines due to the current in the wire. Always remember, if current is flowing into the page, what will be the type of magnetic field lines? The type of magnetic field lines will be in the clockwise direction. Let's make those lines. Let's make those lines. Something like this. Yeah. And what is something that you have to take great care of? The distance between these field lines should increase. The distance between consecutive circles should increase because as you move away from the wire, the magnetic field strength decreases. So as you can see, this black distance is less and this blue distance is larger. So as you go away from the wire, the distance between concentric circles should increase. Let's also, you should mark arrows here as well. This is a clockwise field. Always remember, if current is going into the page, you will have clockwise magnetic fields. Okay. The magnetic field is stronger closer to the wire. State how the magnetic field lines indicate that field is stronger. So you can say the distance between consecutive, the distance between concentric circles, or the distance between magnetic field lines, magnetic field lines increases, distance between magnetic field lines increases as you move away, as you move away from the wire. Simple as that. The distance between magnetic fields increases as you move away from the wire. Simple logical description, one on one. This marks the end of simple magnetism past papers for theory. As I told you, there weren't much past papers for simple magnetism only. However, magnetism is combined with electromagnetic induction, and we have covered past papers in the next video.